Welcome. Let's take a look at finding the derivative of a composition of functions where the information we have about the two functions are provided in a graph. What I want you to notice here is that our two functions, f and g, are captured here in blue for f and in red for g. Notice, though, the components of f and of g are linear, and that's going to be important in helping us to find the derivative here. You might wonder why. So if a function, let's call it h of x, if h of x is linear, that means it can be written as nx plus b, with the lone exception of a vertical line. So if I wanted to find the derivative here, h prime of x would be, slope is constant, so m times 1 for the derivative of x, and then plus 0 because the derivative of the constant y-intercept would be 0. So h prime of x, so the derivative of a linear function, is simply the slope of that line. So we're going to use that to help us find the derivative of the functions we're provided here. So our first function is u of x, and u of x is defined as f of g of x. And what we want to do is find u prime at -2. So the first thing we're going to do is figure out what does u prime of x look like symbolically, and then we can evaluate that at -2. So u prime of x, applying the chain rule, will be the derivative of that outer function, so f prime, and you leave the inner function alone, and that inner function in this case is g of x. So we're going to have f prime of g of x. And then the chain rule says we have to go and multiply by the derivative of that inner function, so g prime of x. So that's basically the template for u prime of x. And now what we want to do is evaluate u prime at -2. So we're going to go ahead and use the information that we have in the graph to be able to do that. So u prime at -2 is going to be equal to f prime of g at -2 times g prime of -2. So to move forward, I really need to know what g prime of -2 is. I'm sorry, that's g of -2, not g prime. I need to know what g of -2 is. So I'm going to come over here to our graph. Here's -2 on the x-axis. I'm going to go down to the g function in red, and I need the function value of that g function at -2. And we can read that from the graph. We can see that g of -2 is equal to -4. So at this point, we have u prime at -2 is equal to f prime of -4 times g prime of -2. All right, so now there's two more pieces of information we need. We need f prime at -4, but we know this is linear, and the derivative of a linear function is its slope. So basically what I need is the slope of the function f when x is equal to -4. So I'm going to come to a -4 on the x-axis and go up and find my function f. And here's f. And what we want to do is we want to find the slope of the line at that point. Now it's linear and it's not changing slope there like it is perhaps over at x equals 3 where we have this corner. So we can use any 2 points on the line to find the slope. And so we can see if we use the notion of vertical change over horizontal change, that between those 2 points, we have a vertical change down, so we call that -1, and we have a horizontal change to the right, and we'll call that +1. So the slope here is -1 over 1, or more simply just -1. So our u prime at -2 is going to be -1 times, and then we need the derivative of g at -2. So using a similar idea, we come over to our 2 on the x-axis and down to our line, our function g, and we want, in essence, the slope, because this is linear, we want the slope at this point. So we're going to pick another point on the line, and it's easiest if you pick points that are on the lattice or on the grid. So we're going to use the point here that we already identified, and we'll go ahead and use this point here because it lies on our lattice or grid. And so the vertical change here for between those 2 points is up 2, so +2. And our horizontal change is to the right 1, so +1. So the slope here is +2 over +1, or more simply 2. So g prime at -2 is equal to 2. So u prime at -2 is the product of -1 and 2. So more simply, it's equal to -2. Let's go ahead and look at another example. So in this example, we still have the same graph, but our function that we're trying to find the derivative of is different. We have v of x, and v of x is equal to g of f of x. So we're going to proceed in a manner similar to what we did before. V of x, let's go ahead and apply the chain rule to it to get our template. So v prime of x is going to be the derivative of the outer function, so g prime this time, leave the inner function alone, multiplied by the derivative of the inner function, which was f prime of x. And now we can think about evaluating this at -2. So we'll go ahead and substitute -2 for x, and we get g prime of f of -2 times f prime at -2. So this is going to be slightly different than what we did before. First of all, we need to know what f of -2 is. We need to find this value so that we can then look at finding g prime and f prime. So what is f at -2? Well, here's -2 on the x-axis, so we will go up to where we find the function f of x, and we want that output value, that y value that's associated with -2 for the function f, and that appears to be 3. So we're going to have v prime at -2 equals g prime of 3 times f prime at -2. Well, at this point, we need to start thinking about derivatives, the derivatives of these functions. So let's go ahead and identify this 3 on the x-axis so that we can think about the slope of the tangent line. So coming over to our x-axis, here is 3, and we're going to go up to our function g right here. So it looks like g of 3 is equal to 6. But notice that we have a corner there. And so we know that in locations where there is a corner or a cusp or some more indeterminate behavior, that the derivative does not exist. So if g prime at 3 does not exist, it doesn't matter what f prime at -2 is, because we can't multiply something that doesn't exist by a number. So in this particular case, v prime at -2, we would say, does not exist. And the reason is that this g prime at 3 does not exist. Let's look at one more example. So we're still working with the same graphs we were before, but notice we have a slightly different function this time. This time we're looking at w of x, which is g composed with itself, so g of x. So let's go ahead and create our template based of the derivative based on the chain rule. So w prime of x will be the derivative of the outer function, so g prime, times the inner function, which is g of x, multiplied by that inner function, g prime. So just to be clear, this g prime comes from g of x being that inner function in our composition. Just wanted to make that clear. Okay, so now we can think about substituting -2 for x. So we end up with w prime of -2 being equal to g prime of g of 2 times g prime of 2. I'm sorry, those are all -2's. There we go. Okay, so first of all, let's get our g of -2. So coming over to our x-axis at -2, you might recall that g of -2 is in fact equal to -4. So we have w prime at -2 equals g prime at -4 times g prime at -2. So now let's go ahead and think about the slope of the function g, this function in red. Notice that both x equals -4 and x equals -2 are on the same part of g, on the same line. So they will actually have the same slope. And so what is that slope? Well, that slope we found earlier was a vertical change of +2 with a horizontal change of +1. So we would end up with w prime at -2 equaling 2 when x is equal to -4 times 2 when x is equal to -2, again because they are on that same line segment and therefore will have the same slope. And of course we showed earlier that the derivative of a linear function is its slope. So w prime at -2 is equal to 4. I hope you find this helpful.